Hello everyone, this is Dr. Hisham Saeed, and in this video I will show you an example of solving or analyzing a cash flow. And as you can see here in this cash flow, it has initial investment of $3,250, and then you retrieve this investment through 15 years, and you can see here initially you start with $250, and this amount increases every year by $10. So the goal is to calculate the net present value, which before calculating anything you need to analyze the cash flow and kind of break it down into the main components. So the first thing is you can see that there is component 1, which is the initial investment. So that's a P value, single sum value, and then the next is the annual uniform annual amount of 250 that happens every year in the 15 years, and then the third is a gradient series of $10 a year. So in the first year, as the gradient series is defined, it is a zero increase in the first year, which is part of the series, and then we keep increasing $10 afterwards. So if you can see here, the year 1, at the end of it you receive 0 increase, and then year 2 you have 10, year 3 you have 20. So that's the gradient series. So you can see now that we have 3 components in the cash flow that if we calculate the present value of each, we'll end up with the net present value for the whole cash flow. So for the first one, the present value of the initial investment, which is a single sum that happens at year 0, beginning of year 1, the present value of it is basically the same. So you multiply by a factor of 1. The present value of the uniform series 250 is multiplied by, you get the present value of it by multiplying a factor P given A. The interest here is 4% over 15 years, and then the third is $10 gradient series G. So you get by the present value by multiplying by P given G, 4% and 15. Make sure here that the number of years N for P given G is usually the same as A, the uniform series that is attached to it. So it is also 15. So once you break down the cash flow and set it up in this formula, you're 90% done. It's just a matter of getting the values for these factors, plug it in the equation, and then figure out what's the total value of the net present value. So how to get these the values of these factors, P given A and P given G? There are 2 ways. You can use the formulas that are given in the textbook, long ugly formulas, but you can also use the tables. So the tables are handy, you get used to them, it's very quick to get values for the different factors. So in this case here, in this exercise we'll use the tables. And the tables are many pages. You know the page by the interest rate. So on the left here you can see it's a 4% interest, and all the numbers here are referring to the different factors or for the different number of years, N. So in our case here, we have 15 years. So that's the line in that page we're dealing with. And we're dealing with P given A factor and P given G. So we pin down here the 2 values, and these are the values we can use. So for P given A, over 15 years, for these 15 payments, the present worth of them is almost 11. So it's less than 15. Why? Because you're dealing with the time value of money. So you happen to have 15 payments of 250. But if you get all of them, or the equivalent value of them right now, it's 11 of them, not 15. And then P given G turns out to be around 69 or 70 as a factor. So you bring these values back to the problem, plug it into the formula. So you can see here, plug in the formulas for P given A, plug in the values for the factors P given A and P given G, and then you end up with a net present value of positive 226.95, which in terms of economics, that's a good investment. Any value that's turning out to be positive, net present value for a cash flow, that's a good investment, meaning that you are getting a return that is equivalent to, or if it is positive, it's actually more than the interest rate you plugged into that cash flow. So for 4%, we're actually getting 4% and maybe and actually a little more. How much more? That's a good question. So how much more? You need to find this by doing an internal rate of analysis. So that's a whole different type of problem. But currently, you know that you're getting the 4% or return that you're thinking of, and more. Anyone that has a minimal attractive rate of return of 3% will also be happy, and actually more happy than the one that has a minimal attractive rate of return of 4%. So in this case, the conclusion here for this problem is it is a good investment, and that would be the end of the exercise here. I have another video to show you how to do this problem in Excel. So please look for the link for this, and I hope you enjoyed the exercise and the way it was done and solved. Thank you.